that we found in Lab 1. The fundamentals of this lab are using tape to model electric fields of distributed charge, using Newton's second law, which is force equals mass times acceleration, and Coulomb's law, which is force equals the charge times the electric field, in order to calculate the charge on each piece of tape, and using superposition in order to find the charge distributed across each piece of tape in the most accurate manner possible. With regards to the results, I found that the force of gravity should be equal to the electric force, which is about 2.17 times 10 to the negative 3 newtons. The charge on each piece of tape is approximately 2.88 times 10 to the negative 8th coulombs using this model, and using superposition of segments provides a much different and more accurate result than treating the entire piece of tape as a point charge. With regards to the assumptions and models that we used, each piece of tape was modeled as several equal segments, with each segment being modeled as a point charge, each with equal charge, in order to apply the properties of superposition to find the charge of each. We assume that air resistance is a negligible force. Each piece of tape has the same amount of charge, and the charge of each piece of tape is equally distributed along the length. So with regards to the experiment, it was the exact same experiment that we did in Lab 1, where the system was tape B and the surroundings were everything else. The initial conditions were the two pieces of neutral tape, and we charged them by sticking them down onto another piece of tape and ripping it off quickly, allowing them to be positively charged, as we found out in the first lab. With regards to the data and calculations, I found that these numbers quantified the tape mass, length, and the distance between the pieces of tape. I found that the force of gravity on the piece of tape was about 0.00217 newtons, and that since the acceleration of the tape is 0, the electric force exerted on tape B by tape A must be equal to the force of gravity on tape B, and I was able to derive this equation for the charge, which was 1.34 times 10 to the negative 8. Keep in mind that this is under the point charge model. Next, we'll move on to my computational model. As you can see, I first initialized the constants and the properties of tape B that are relevant to this model. I then use the following lines of code on the bottom left side of the screen and on the right side of the screen to first initialize a function for an electric field, and then to define the function for the line